Okay. So isPermutation takes in two lists and asks if they're permutations to each other. Now, permutation and combinations are two of the basic things of combinatorics. A permutation basically is a specific ordering of something, and two things are permutations if they are in the same order and have this and this. Sorry, two things are permutations if they have the same elements, but they're just arranged in a different order. So, for instance, a deck of cards. When you shuffle a deck of cards, you create a permutation, right? A deck of cards has 52 factorial permutations because there are 52 factorial different ways that it can be shuffled. With the first card having 52 possible different cards it could be, the second card being 51 possible cards, the next card being 50 possible cards, and so on and so forth until we get to one for the last card. And so you've got 52 times 51 and so on and so forth. So it's 52 factorial. So decks of cards are basically the classic kind of permutation. Here we see two words, wolf and flow. And if you sort them, basically we can see that they are permutations of each other. Wolf and flow are made up of the same letters. And that's another way to tell if two things are permutations. If you can sort them, they're going to have the same arrangement. So you can easily see that they're permutations of each other. We can see that these two numbers over here, that these two lists of numbers over here, 1, 1, 2, 3, 3 and 1, 2, 3, 2, 1 are not permutations of each other because they do not basically sort into the same thing. Or more specifically, they do not have the same number of elements. Those are the same elements and the same numbers of elements. Like they both have ones, they both have twos, and they both have threes, but they have different amounts of ones, twos, and threes, right? This one has 2 ones, 1 2, and 3 threes. This one has 2 ones, 2 twos, and 1 3. Now, if I were to swap this around to say 1 1, 2 2, 3 3, right now they'd have the same number of ones, the same number of twos, the same number of threes, and that's what makes them permutations of each other. Make sense? So a question becomes, how can we write a function that tells if two things are permutations? So first thing is that, of course, it's a Boolean, because when we're asking this is a question, is this thing something or is this another thing, we basically are asking true, false. So is this a permutation or not? So we do a Boolean. Now, the strategy you always want to use for permutations is to try to prove try to do a proof by contradiction, essentially. Assume something to be true, and then think about what's easiest to say is false. So is it easier to prove something is to show something is a permutation or isn't? And it's much easier to show that something isn't a permutation because because trying to show that two things are permutation sounds a bit difficult. But for two things aren't, we just have to show that they have separate amounts of numbers and stuff. Okay, so what I'm going to do is I'm going to assume true. And then I'm also going to use this very easy base case, which is this very easy assumption I need to make, which is that, hey, if the two things are not the same size, return false. So if list A is not equal, and again, my font just does fun things where if I put two symbols together, it turns it into a mathematical symbol. So if list A and list B are different sizes, they can't be permutations of each other. They just can't, because they aren't going to have the same number of items in one of the categories, at least. So we can assume that basically that for two things to be permutations, they have to be the same size. Okay. So now let's talk about my assumption here, which is that I said basically if you can sort two things, you can then say, if you can sort these things, you can then say, hey, they come up with the same thing, they must be permutations. So if we sort them and they end up being the same thing, then they have to be permutations. So how do we sort things? Well, let's look at the list function. Lists are collections. And there is a collections. So there's just like there's an arrays class that has a bunch of useful stuff. There is a collections kind of class, which has a bunch of different methods in it, specifically sorting. Okay. So collection. So there's collections, which has all this kind of really useful abilities. And I'm just trying to see if it's got a really, I can't just look it up. Okay, then just take my word for it on this one. But collections in java.util has a bunch of different things. Specifically, we look at this and it's got, hey, empty set, empty list, which, what do these do? These produce, I guess, an empty set, or do they check? I don't. Oh, it says it returned. So it would give you an empty list or an empty set. Pretty useful. All right. Then it's got this useful sort method, which takes in a list. That looks pretty much exactly what we want. Given a list, it's going to sort it. Now, I say it like it's not going to do that. But no, the sort function does exactly what you'd expect it to do. And let's see. So, and yep. So notice that this is a sort function and it's got something horribly looking over there in just a second. It is going to be stable, a stable sort. So these are parameters for sorting. I'm just trying to check which one it's going to use. I forget if it uses Tim sort or okay, 1 second. Adaptive iterative merge sort. Okay, so yeah, it's going to use Tim sort to sort things. Okay, which is, and we'll go over that much later in the semester. We'll talk about that. So collections.sort will sort a list. So, okay, I'm going to go ahead and sort list A, and I'm going to sort list B. And it will sort them in place. So it's going to change the list themselves to make them sorted. And then all I have to do is say if list A equal dot equals list B, if they're the same now, right? Let's check what the dot equals does. Returns the hash code. It's the list. It's says that basically, so make sure that everything is the same. Let's see, compares. Both lists are the same size and all the corresponding pairs of elements in the two lists are equal. So in other words, it's got me. So for two lists, so when we use the equals operator on two lists, it's doing exactly what we'd expect it to do. Are the lists made up of the same things? So that's what we're going to ask. So if list A is equal to list B, return true. Otherwise, we're going to return false, which we could just actually simplify to just return this statement. Okay, but I've got errors here for some reason. Now, I don't understand why. Well, I understand why, but like you're looking at this and you're going, I don't understand why I'm getting this. Is it because list T provided list D? The variable. Okay, and we see if we change this to T, right? You're like, okay, so E and T don't match. Okay, I guess I have to use the same variable for some reason. Boy, that's confusing. But no, that's not the case because look, we passed in T and it's saying T. So now reason, no instances of type variables T exists so that T conforms to question mark super T to comparable. Wait, what? So this is the other powerful thing we can do with generics, which is that we can put restrictions on what kind of things a method will take, or what kind of class a method will take. So I asked it to sort a list, but a list can hold anything, right? Typically, it's going to hold stuff like integers, which can be sorted, or strings, which can be sorted. But what if I pass it a list of servers? How do you sort How do you sort servers? How do you know when one server should be first in a list versus another? Or scanners? How would I sort a list of scanners? You can't. Not everything can be sorted, right? Because sometimes sorting doesn't make sense. So what does that mean? Well, anything that can be sorted in mathematical terms has a natural ordering, okay? And so what we have is that we have a way of saying, hey, these objects can be sorted. And that's by saying this object is comparable. So what is comparable? So comparable is an interface. Let me go ahead and pull it up. Comparable. It is an interface, meaning we can just add it to any class. And it says basically this has a natural ordering. This class has a natural ordering. And it has one method called compare_to, which returns an integer. Okay. And so let's go ahead and take a look at this in context. Okay. So pretty much every object we've dealt with that you can be sorted is comparable. So let's take a look at numbers and words. So first off, integer. Look at the integer class. Look at this. Final class, integer number. So what does it mean to be a final class? That means that nobody can make a subclass from it. Extends number. A integer is a type of number, and it implements comparable integer. This means that integers can be compared to other integers. So watch this. So if I've got integer a is equal to, let's say, 10. Let's go with actually 5. Integer b is equal to 7. Here's what we can then do system.out.println, and because they're integers, we can do dot compare to, which compares it to another integer. Okay, so I'm going to compare a to b. So if I run this, I'm going to get -1. Now, -1 means that basically when we do when you do it compare to, you're going to get one of 3 things. You're going to get as it says in the return statement over here, you're going to get a value less than 0 if this thing is less than the argument, 0, and a value greater if it's greater than the argument. So a compared to b, if a is less than b, or if a better way to think about it is that if a comes before b, then we're going to get a negative number. Here we got -1. If we do it the other way around, b dot compares to a, because a comes after b, we're going to get a positive number. And if we change these values from, like, say 5 to 50 and do a dot compare to b, we get 1. And now if we set them equal to each other, we're going to get 0. So it's kind of very useful. It's useful for writing sorting methods. We won't need to use this until we get to trees, but it's good to kind of talk about it now. Now, okay, well, what about for strings? Well, same thing, except that, like, strings aren't less than or greater than, really. We don't think of them that way. We think of sorting them alphabetically. Apple, banana. Okay. So now A dot compared to B, because apple comes before banana, we get a negative number. We get -1. Although, very interesting, if I put hello and I put world over here, I'm still going to get a negative number because hello comes before world alphabetically, but I get -15. And the number you get here is the alphabetical distance from one number to another. So if I do world and hello over here, we're going to see that we get a positive number instead. If I do world and then zebra, we're going to see that that's a much less number, -3. Okay, so bottom line is that if things are comparable, then you can sort them. So, so these errors were cropping up because if we look at the collections.sort, there's a restriction here. It says this, which is a lot to take in. It says this takes in a list of T's, but what are T's? Well, T's are any type that is comparable to anything that has T as a superclass. That's what this question mark means. Will you ever have to write this bit? Not in this class, or rather not this bit, this question mark super T. But let's go ahead and put a similar restriction on here. So what does this say? This says, and this is much easier to read. This says that basically that isPermutation takes in a list A, and a list B. List A and list B can be any type. They just have to be the same type. And E, that type E, it has to be comparable. It has to be of the subclass comparable. And what is it compared to? E. So basically it's saying that isPermutation will take in any type that is comparable, any types that can be compared to itself. Which makes sense, right? We compare integers to other integers. We compare strings to other strings. So, and then now this all of a sudden works. Now that being said, this doesn't do it for every type. So we'll take a look at, we'll take a look later at like, how do we get this working for every possible type? Because there's another way to do it, which is a bit messy. But it works on any type and you don't have to use the comparable stuff. This is the only thing where you have to do this comparable declaration because you're trying to sort things. All right. Now for the last problem, which is the remove all instances method. Let me go ahead and write the method declaration for that. Public static e void remove all instances list of e target. So we want to remove or I'll call it item. We want to remove this all instances of this item from this list. And because it's a void method, that means that we're modifying the original list. Now, the reason I bring this up is that you want to test out the example I give you in the document, because it's very easy to make an accidental mistake here where we don't remove everything we would think to everything we think we would. So just keep that in mind. But I just want to clarify for that last one, it is a void method. All right, any questions before I let you get back to work? All right. Let me know if you have questions.